Hey guys, I just spent the last hour and 10 minutes recording for you using the Promethean software, and then I get an error. So, unfortunately, I'm going to have to go through it this time and just explain my work. Some problems I'm going to have to do over again, but um, it's been a bummer. I'll show you the work so you'll at least have the answers. So number one, we have to use the sum or difference to find identity to find an exact value. And the first thing I did is I took the 7 pi over 12 and converted that into degrees. And then I got a 105 with degree measurement, and then I figured I could break that apart into 60 plus 45. So I used that with my sum formula for cosine, and eventually found that we have root 2 minus root 6 over 4. So let's go to the next one here. For number 2, want to find out what the sine of 75 is using the half angle identity. And so the first thing I did is I actually wrote down the half angle formula for sine, and I noticed that 75 is taking the place of the u over 2. So I set 75 equal to u over 2, and I solved for u, and that gave me 150. So I plugged in 150 into the u spot. And so I used the plus instead of the minus because we're finding the sine of 75, and the ratio of sine in the first quadrant there is positive. So I ended up simplifying to get a 1/2 times root 2 plus root 3. Alright, let's see what we have for the next one. Okay, so for number, I'll talk about number 5 and then I'll jump back and do number 3 and 4 with you. So number 5, you want to figure out the angles that will satisfy the equation. So the first thing I did is I made a substitution into the sine of 2 times theta. That's a double angle identity. That's 2 times sine theta times cosine theta. And then I subtracted cosine theta to both sides. So I ended up with sine of 2 times theta times cosine theta minus cosine is equal to 0. And then from there I noticed I had two terms that have cosine. So I factored out cosine here, and I set my two factors equal to 0, and I solved. And that's what you do with all these problems. You set your factors equal to 0 and you solve. So I ended up with a cosine of 0 equals cosine of theta equals 0 and sine theta equals 1/2. And I wanted to find the angle value that will get a 0. So I look at the ratio. What's x over r? Where's x equal to 0? At 2 spots, here and here. At pi over 2 and at 3 pi over 2. So what about 1/2? You have 2 spots in the first and the second quadrants. So 1 and a 2 and a 1 and a 2. Alright, so this is a 30 here, and 30 is pi over 6. 180 divided by 6 is 30, and the other value is at 150. And how many 30s fit in 150? 5 of them. 5 times 30 is 150, so that's 5 pi over 6. Okay, so that's our solution there. Let's go ahead and move to number 4 here. For number 4, I would need to I could actually just factor out tangent from both of those terms, and I have 2 times cosine minus 1, and set tangent equal to 0, and root 2 times cosine minus 1 equal to 0. That's going to end up giving us a cosine of theta equals 1 over root 2. So we got to figure out what angle is going to give us a 0 for our tangent, and we have y over x for tangent. So where do we have a y value that's equal to 0? 2 spots. At this position here and at this position here, which means that theta is equal to 0 and pi. Notice I'm not including 2 pi. Okay, so the next one here, we could rationalize our denominator for this ratio and get a root 2 over 2, which might make a little more sense to you. Or we could just say, let's work with what we have right now. And we have x over r, which means we have a 1 and a root 2 here. Now, if I were to use the Pythagorean theorem and solve for that unknown side, I'd find I have a 1 there. And that means I have an isosceles triangle, which means that these two angles are the same here, which means we have 45 and 45. And that means that the solution here is going to be at pi over 4. That's one solution. We have another triangle to look at the fourth quadrant. And we're going to have a 45 there too. And how many, we're at 315. And we say how many 45s will fit in 315? Total of 7 of them. So that gives us a 7 pi over 4. 7 pi over 4. Alright, so let's deal with number 3 there. Number 3, we have this equation that looks almost like a quadratic that we could factor. The problem is that we have two different trig identities in there. We have a cosine and we have a sine. Let's go ahead and make a substitution in for cosine squared. Let's get this equation. Let's manipulate this equation so that we have only sines. And remember that cosine squared is in the Pythagorean identity, and we could manipulate that identity so that we have cosine squared equals 1 minus sine squared, which means now we have 2 times 1 minus sine squared minus sine minus 1 is equal to 0. So let's go ahead and distribute in that 2, and then we'll combine some like terms. Alright, so we have the 2 minus 1 is a 1, and I'm going to multiply everything by a negative. And that's going to give me a quadratic that I can factor. And I have a plus and a minus there. So that gives me the sine theta equals 1/2. We just did that. That was at a pi over 6 and 5 pi over 6. So I'm going to go ahead and just write that down. The other one here is that sine of theta equals -1. That occurs at one spot right here. When x is 0, y is -1. That's at 3 pi over 2. 3 pi over 2. Alright, let's jam. I'm running out of time here. So first thing I did on this one here, number 6, is I changed everything. I changed the cotangent into terms of sine and cosine as cosine squared over sine squared, inverted and multiplied, and then from there I had a common denominator, so I added them up or subtracted, and then I factored out a sine and then made a Pythagorean substitution. and then I ended up with cosine squared crossing off with cosine squared, which gave me negative sine in the end there. What happened to 7? Did I erase that? My goodness, my computer is really acting up on me today, guys. Oh boy. Alright, I'm jumping to 8 right now. 8. I want to prove the identity, so I first started off by making a substitution into tangent. Changed everything into terms of sine and cosine. And then got the common denominator and made the Pythagorean substitution in the numerator there. And let's go to the next one. Okay, so in number 9, I was trying to manipulate the left and the right, and I noticed that I wanted a sign on the right. I wanted a sign in the denominator, so I multiplied the left by sine over sine. And I multiplied the two signs to give a sine squared up top, but I kept the denominator factored. I didn't distribute the sign because I want that sign down below there. So then I made a substitution in for sine squared. That's 1 minus cosine squared. That's the Pythagorean identity. And then I had a difference of squares that I factored, and then I was able to cross off a couple factors in the numerator and denominator, and that proved it for me. Okay, next one. I wanted to add up the two fractions there on the left, so I got a common denominator, and I multiplied the numerators, but I kept the denominators factored because I noticed that I want a cosine in my denominator. I'm thinking about what I'm trying to prove. 2 times secant. Secant is 1 over cosine. And by keeping these factored, by not distributing, I have the cosine down below, which is what I want. So cosine squared and sine squared, and the numerator gives us a 1, and then 1 plus 1 is 2. Then we factor out a 2 from the numerator, and we can cross some things off, and that proves it for us. Okay, jamming. Okay, so 11, I noticed that I had a identity in the numerator. So Pythagorean identity. So I made a substitution, changed everything into terms of sine and cosine after that, inverted and multiplied, and ended up proving the identity. 12, similar, I made a Pythagorean substitution in the numerator, factored the difference of squares, changed that secant into 1 over cosine, got a common denominator, and that proved it. Okay, so 13, I changed everything into terms of sine and cosine, got a common denominator, and then factored out cosine squared, made a substitution into that spot for a Pythagorean identity, and then that proved it. Okay, I'm running out of time here. Yikes. So on this one here, there is a lot going on because I had to make several different, I had to use the sum or difference formula a total of 3 times. And so I'm going to go ahead and stop here and save this. Screencast-O-Matic only gives me 15 minutes, so I'll upload this video. Hopefully this helps.